Testing. 1, 2, 3 testing. So I guess we should start because of time. So this is the first class for the DSME 2011 with the cancel the Monday class because of the inauguration ceremony. But it shouldn't affect our schedule. So so this is section. I think this is the section C, and I also teach section E. So everything is the same across the two sections, but try to attend your own section because of COVID control. So I'm the instructor for this class. Here it shows my office. Oh, by the way, is anyone in the Zoom can hear me? It's okay. Hear me? Okay, good. So so this is my office in the B school, and you can reach me by email. Look at my website about my details. And for office hour, yeah, because I know everyone have different schedules, that it's better to be by appointment. But most of the problem, usually logistic or technical problem, probably solved easier by the TA because TA grade your assignment. Most likely your problem will be with the assignment. And if your problem with the class material, usually I stay around in the during the break, and after the class is over, it's easier to ask during the time. But of course, you can schedule appointment. But of course, again, the TA will be better to serve you at the beginning. If he cannot solve, then he'll help you. So just a little bit about my background. So I did an undergrad here in B school, and later I do a master's degree in econ department, which is also here. And I go to US to do my PhD study. And during the time I'm a PhD student, I did teach statistics class for 2 years. And after I graduate, then I go to Singapore, where I taught not statistics, but statistics applied in finance. And now I come back to Hong Kong for 3 years. So I taught this class for 2 years already. So it's the third year teaching this one. So pretty much I think I'm familiar with the material, so then be an issue for you. But and the material, as you will see, will be, as I discussed, is very similar across the 3 years. So shouldn't be a surprise to you if you know last year what is it about, and then it shouldn't be any new big changes. So our TA is Austin. He's not here today, but he has been TA for several years, and he has been with me for 2 years already. So I think he's a well-experienced TA. So just feel free to contact him by email. He's around always. So this course is basically statistics and applied to business application. And as you can see, these are the main topics, right? We will start with the descriptive statistics, probability, estimation, inference, regression, and ANOVA. And of course, for our purpose, for application, the last three topics are the main thing, right? And what are they? And then they basically is just trying to use data to make some conjecture, make some guess of what's going on in the whole picture. Just like we want to know, say, how is the effect of certain medicine, right? Then what we're going to do is collect some sample and give them the medicine. Let's see that medicine can help to cure the disease, right? We are not always giving all the medicine to every people because of the cost, right? And you make some prediction, right? And that is the inference thing. And we will generalize this to call ANOVA. ANOVA is a classically built from doing some experiment. You experiment A, B, C, D, E, different treatment, and see different treatment have different impact, right? That's usually how you try to see, suppose you have medicine, you know it's going to be effective, right? But what is the proportion? What's the portion of that? Then you will try the different treatment group, right? That's the standard way to do. And this is actually coming from the classical people doing experiment, right? Different rice, right? Try different rice, different way to cook the rice, right? This very often used. And the last one is regression. Regression is I would say, the most commonly used way in statistics. And as you see, if you go one class beyond, I think our class is 2011, maybe 2021. I think the whole course is about regression. And basically, you can say advanced econometrics is basically everything about regression, right? Try to explore what is the relationship between one variable versus the others, right? How they're related, right? And that is basically what the AI, right? Artificial intelligence and machine learning is, right? You try to say auto driving, right? It's basically look at what's the input, right? What are the visual sign of there's a car, there's a dog, there's a people there, you try to stop, right? Don't run over it, right? And there's a red light in the stop, right? So they're the input, right? And the output will be how to drive the car, right? Again, it's like regression, right? Just like some input and some output, and try to figure out from the data, try to figure out what is the best fit, the best relationship to that, right? So that is the idea behind this class. So I mean, this is a required class, right? So that's why you go to choose other section with same. Okay, so there's no innovation of the material between our section to the others, just the way we present. Okay, so so that's why we share the same course outcome. Okay, the only difference between my class and the other one is we have R and Python, which usually not covered in other class. And this is the main difference between this year and last year. This year we don't have R in our main lecture. Okay, because luckily this year we have, later we mentioned, is we have other TA that help us to cover the R and Python. So that will be optional tutorial on Friday. So you may or you may not want to go, doesn't really matter. Okay, so but I recommend you go there to learn R and Python. And of course, if you don't like to join tutorial, we're lucky that this year, again, we have a support from DataCamp, which is an online website. I think it's very useful to learn programming by yourself. So you can go there, DataCamp. We have, let's see the website here, DataCamp. So this is the website there. where we have usually you need to pay for that. How much you have to pay? I think you have to pay $12 US per month to learn, but luckily they support us for free, so you don't need to pay. So I think the membership is until next March, so 3 months more than after our class is over. So we learn it. After the class is over, I cannot extend because it's just offer for this class. So you can register the link in our course website. Okay, just don't share it with your outside the classroom because the license is restricted to our class. Okay, even if they are in the, you share with the section C and E people is fine, but outside no, because I only apply license for us. Okay, and this is the main topic discover, and later I will discuss in another document overview, but mainly speaking, if you study high school here, okay, basically you would cover 1/3 of them in there already. Of course, we cover more detail, but 1/3 has been covered in high school. And if you do additional math, M1, I think it's already covered up to half of it, up to the interval estimates. Okay, and probably what is new is hypothesis testing, regression, and ANOVA, which are not in the high school syllabus. Okay, and these will be the important tools for our purpose. Later you will see when we do project, that is the main goal we're trying to do. Okay, we're trying to make sure that in your project after this class, the main goal is make sure that you know how to use these three tools: hypothesis testing, regression, and ANOVA. This will be most commonly used tools in statistics. So is there a question until now? If no, then I talk about assessment. Okay, probably most of you would care about this. Probably say your main reason why you choose this class or choose other class. So for the test, we have 50%. It will be an open book assessment. Different from last year, we have 1 hour only. So it will be conducted on the Friday of last week. I plan it to be, I think it's on the, after the edge of period, I will send out to ask the time. But it will be Friday, December 2nd, at the night, Friday night there, probably maybe 5 to 6, 6 to 7, or 6, 7 to 8, depend on everyone's availability. Okay, just 1 hour exam is open book. The format may be very similar to last year. I mean, later when things are close to the end of semester, I will release the past papers and then you can take a look. But I will not release with the answers, but just the question I will discuss, but I will not release the solution. I will discuss over it. And so the test cover everything. If you have to absent from it, you need to have a valid justification why you not doing it, and I'll give you makeup. But so far I haven't given makeup so far because I think it shouldn't be an issue. We announced so early, so you should be able to make it just 1 hour. Okay, and class participation, attendance is a natural thing to be there. I will not explicitly take attendance for our class. So far, we probably don't need, but if I got a recommendation to have taken, I will take it, but usually I don't. So then I expect if you attend this class, you should be in the class. So doing the thing you should do. And if I make a quiz, then maybe I build a quiz, but probably not sure if I have time. Okay, if I quiz, then I put a quiz as a percent, then I will do. But last year I planned to do quiz in the class, but I don't have enough time, so I didn't do it. This year I don't know we have time. If we have time, we just do a quiz. Yeah, but quiz will be just you get pass or fail, and that's it. So homework, and I plan to have 6 assignments, and then you have the lowest one we drop. And the assignment will be graded by the TA. Okay, everything related to assignment, you should contact the TA. And the assignment will be just application of what we taught. Okay, so it's not something complicated, but you should know how to do it, just to make sure that you know how to do it. And for project, we'll talk about later, but the main thing is to try to make you do the last 3 things. I will give you more detail about project soon, but although the project only worth 20%, I would say it is the most important thing in this course, actually, because it's how you apply the technique, right? Although I put 20%, it doesn't mean it's low importance. In fact, I think it's the most important. And you may ask why I put so low weightage. Weighting here is because of this grading of projects is rather subjective sometimes. Okay, I think I should put more for fairness reason. I put the objective test to be higher percentage, right? Because the project is graded by me only. I mean, it's very difficult to have a very subjective one, so very objective one. So I mean, unless I have multiple grader, they would be more objective. But so that's why I try to make it lower. But I think you should try to do better on this one, because this is the main way to learn. I mean, I'll give you an example or guidance later, so don't worry. I will give you more detail. So it's still weak a little bit here, but it shouldn't be soon. Grade descriptors. This is standard, so I don't have any particular thing to say. And probably I have taught this class for 2 years, so probably you know my grading criteria implicitly from other seniors. So there won't be any changes. So the next item is textbook. This textbook is shared same among all the sections for the same class. So I don't have anything to say. If you want to buy and read it, feel free to do so. It's not, although it's required, but it's not. We're not assigning assignment based on the textbook. So you may ask, if you don't have it, it's okay. Yes, okay. You don't have to have it. If you want to have it, or you have earlier version, also fine. You can pick up any statistics textbook, also fine. Okay, doesn't really matter. And as you probably look at the blackboard, then I have a lecture notes here, and which is this already contain everything I want to say, more than what we want to say. So if you want some extended material, you can download this ebook, and then it basically based on the slides we have and with some extension. So I guess if you want some extended material, you might try to read the book. That would be, I think, is good enough. But of course, if you want more formal treatment or formal textbook, you can just pick up the book from the bookstore. And the other book is reference book. I mean, you can read it. This one is more related to business. So you want to see, but and here the reference book is basically for you if you want to know more. It's more advanced test. But I guess it just put there in case you want to know more. Because of some of the proof we omitted in the class, and you may want to, if you want to know, you can find all those there. But now, I mean, in these days, the reference book is not really, reference list is not very important because you can always Google it, right? So I don't see too much meaning here, because no one actually look at those, but just put there for those you have a rare need of doing it. So standard, if you have any feedback, you can always talk to me and email me or the TA. Of course, there's a formal feedback at the end of term. Okay. And particularly if you think I go too fast or go slow, and let me know, or it's not very clear, then just ask. Since we don't have a very big class anyway. So this is the schedule. I think we missed 2 classes. One is Monday and also next Monday. But I guess we should still have enough time, no need to make up, because we already have an extra class at the end for the test. So probably if we have to do is make up one more class, but at this stage, I don't think we need to. Depends on the situation, but I think we're safe. Because last year we covered R in the class, but this year we don't cover R, it's put in optional. So already I think we have extra time. So it shouldn't be an issue. If we need, I will let you know. Okay. In that case, we do a makeup, then I will, in the makeup class, I will allow you to do it in Zoom if needed. I will do a physical one as well as Zoom as well. For that one, I don't think shouldn't be an issue if we do, but I don't think we need to at this stage. So this is the schedule. I guess it's not something, it's something that we try to follow, but we don't have to. And as I said, for programming, we will cover Excel only. And surprisingly, still for business application, Excel is still the main thing. Unless you are doing some data science, R and Python maybe there, but R and Python cover in tutorial. So I will focus on Excel. And everything Excel is in the slides already. And I mentioned about the data cam. And finally is honesty. You don't need for this for your assignment, okay? Only for your final project, okay? And later you see the final project, only 2 pages. So I guess this one don't apply as well, but you just do it. But you just limit the number of writing anyway. So shouldn't be an issue. But for the project, you should submit this one. Other than that, what do I have anything to say? So for this course outline, any question? Any question, any comment? I guess if not, then I talk about the topics overview, because this is trying to make sure that you know our class is a lot of material, but most of them you have learned, right? Because the idea like this, you can see we have topic 1, 2, 3, 4, 5, 6, 7, 8 topics, right? And if you go down and look at the detail, you can see, okay? And I put a superscript JS means that you learn in junior school. Junior school, I refer to the Hong Kong high school syllabus, okay? So secondary school syllabus, you learn in junior school, the mean, median, mode, of which we covered today. You also learn the range and interquartile range in the senior school, variance, standard deviation, you learned it already. So we just knew for the topic 1, maybe some correlation coefficient, skewness, kurtosis, covariance, and the bar chart, pie chart you learn in the junior school and senior school, okay? Why I call JS and SS is the way that the Education Bureau write in this way. So it's not my invention. That's called the junior school is from secondary 1 to 3, and then 6 to 4 is the senior school. So for probability, also learn in junior school. Some of them you learn senior school. So only new thing if you don't have M1 is the base rule. So if you don't M1 is already there. If you don't have another M1, then we will learn base rule. So basically topic 2 is already there, already learned it in your high school, most of them at least. If you're M1, then you learn everything. But of course, we'll get a little bit more detail, but we assume you don't have any knowledge on that. Should everyone think I'm going too slow, then I can just go faster on those topics, right? And look at topic 3, random variable. If you learn M1, actually you learn almost half of it, right? And the most important is the normal distribution. It's a bell-shaped curve. I think everyone do senior school, right? You learn the normal, the bell-shaped thing. So it's not something, most of the things you have learned. There's some technical detail here, but this topic also is well covered. Right? Later you do sampling. If you don't do M1, then you haven't learned, it's new to you. If you learn M1, half of it already done there. Okay, of course, in M1, you don't go to the mathematical foundation, we try to give you those, why they are true, how they can be used. And for estimation, you also have learned from M1, half of it. If you haven't done it, of course, it's new to you. And for the rest, hyper testing, ANOVA, and regression is not covered in the high school syllabus. Okay, so but that will be the main purpose of this class anyway, and they're the main tools to be learned. So and so just showing you this is trying to telling you that if you do senior school, of course everyone do. I mean, you have 1/3 of it. If you do M1, you already have half of it. So and then the rest will be the new. But of course, I would, after so many summers and holidays and things, I would assume you have nothing. So we start from scratch anyway. So in something we skip, maybe the thing we only skipped in our class that you should know it is drawing graph. Okay, how to do pie chart, how to histogram, how to do bar chart. I'm not covering. Okay, they are covered in your kindergarten. Make no mistake, my daughter is 5 years old. In the kindergarten, they already do bar chart. So if you don't know how to do it, ask your cousin. Okay, it's a 5-year-old curriculum. So this is something we skip. Okay, for new diagram like box plot or scatter plot, which is relatively new, I will talk about that. Other than that, I will assume you have no knowledge about that. Okay. Probably I just give you overview a little bit about what is covering here, just within 5 minutes. So descriptive statistics is mainly trying to say I have a data set, data there. I'm trying to, because data now is, in the old days you hand collect data, the data size is very small. Right now we have computer, the storage problem and collection problem is gone. So we can easily get huge amount of data. Right, and then the question is how to represent them. Right, you learn from the high school or even your kindergarten girl already. They know how to simplify data using bar chart, pie chart, those kind of things. Right, and you learn from high school. You learn what we call the summary statistics. Right, the mean, the mode, the median, dispersion, those kind of things. So basically, it's this one. Right, so basically, given data, how you describe them. Right, and then the question is, what is the meaning of this data? Okay, how can we extend from the information and knowledge from the data? Can we learn more about the thing? Right, and if the data is already contain everything you want to study, then that's fine. Right, suppose you collect all the data. Say suppose the administration and the CHK, right, it has all the data for its own student. Right. If we want to make some study on it, it's fine, right? But if we want to use this data to infer what's going on in Hong Kong, then it's a problem, right? Because we don't know what happened in Hong Kong Hong Kong UST or other school, what's going on, right? Even we restrict to college student, right? There's an issue there, right? So the problem, what we're doing is we never have enough data collected for this thing you want to study, right? We only usually, most of the time, we only have a subset. Well, just like if you look at, you want to study behavior in TikTok or YouTube or Facebook, right? If you look at the whole full sample, it's impossible, right? You only collect a subset, right? Probably you know the very famous court case between Elon Musk and Twitter. It's about the bot or robot. It's the non-human account in Twitter, right? And they are never able to audit everything, right? They only collect a subset of it. And try to say, if you have this subset, is it going to, they study the result from this sample is going to extend, right? So you're just looking at the small part of the picture and then try to infer what's going on in the big picture, right? So that's why we need statistics. We need to learn probability because we're not going to, we only look at something trying to infer the big picture. So that's why we need to learn probability and random variable is to build up the foundation to understand when we try to study a subset of the thing we want to study, okay, when it's going to valid, okay, how good is our guess based on what we have, okay. So that is the reason why I study topic 2 and topic 3. Okay. And then based on topic 2 and topic 3, then we study the rest, right? The sampling distribution is basically, as I said, is based on you're studying a sample, which is the small part of the whole picture you want to study, and try to look at what is the property of those. And then based on this, we can come up with everything below, like estimation, right? You're trying to make a guess based on what you observe, right? Suppose you want to know is how likely a population has certain kind of rare disease, right? Unlike COVID, right? You can test everyone, right? The government say 599G and go to test, right? COVID, you can do it, right? But for some hidden disease, you cannot do it, right? Of course, you can say I have a lot of money, I can check 7 million people in Hong Kong and check every single one, the blood, and that's it, right? But sometimes it's very expensive, you cannot do that, right? Then what we're going to do is randomly pick up something, some people, group people, and test it and make a conjecture, right? So that's an estimation, okay? You're trying to estimate. And that's often happened in election in the Western country, right? Look at who is going to be elected, right? And the people could make a prediction. And what they do is usually they pick up 1,000 people to make a guess of several million people, right? Look at US election, right? It's more likely like 10 million people, right? But often the time they only collect 1,000 voters and turn out to be those estimates rather correct, right? How can you do that? By 1,000, you predict 10 million? No, not 10 million. I think it's 100 million, right? 100 million people. How can you make that conjecture? So this estimation is an educated guess from the data. Okay, so that is the first thing. And the second thing is called hypothesis testing. Okay, or for estimation is very useful for business, right? That's how you do estimate what is going on in the stock market and how estimate the demand, those kind of things. And hypothesis testing is very useful when you talk about audit accounting, right? Or quality control, right? And suppose you are the auditor, right? You want to check whether the company have set so much inventory, right? You have to go to there and check their inventory check, right? And for a company in a big scale, they have maybe, say, if a company that have a business in China, many cities, right? You cannot physically go to everywhere, right? You have to pick up some location and check a particular warehouse, and even that can be large, right? You may want to pick up a particular good there and check, right? So the question is, they claim they have certain amount of inventory, right? And then you just randomly pick, right? And in that case, right, hypothesis testing tells you whether those of thing would be valid, okay? And the other one commonly used nowadays is you do a RAT test, right? And then if that is less accurate, right? And then you need to do a PCR, right? And then how many PCR you needed or how many RAT you needed to make sure that it's going to be going to make sure that you are got a disease, right? Is hypothesis testing, right? You have something you want to test, and then you see whether it's true or not. Okay, and that is very useful. And for statistics, it basically you are say you are the medical studies. Most of the actually what we do in the next two will rely on hypothesis testing, right? The reason why we need is because once we have a model, say suppose we have the data, we generate a mathematical model, try to explain things, okay? But what we getting there, what we have estimation there, is it a valid thing, right? Is it a valid thing? We rely on hypothesis testing. We want to see whether our result are real result or are just coming from randomness. Okay, so that is the main thing we want to study. And ANOVA and regression. So ANOVA, analysis of variance. It's just very simple thing. It's just saying, as I said before, it's just like you have multiple treatment group, okay, and you want to see whether different treatment group may make a difference, right? That's very important for product research. Or if you're marketing, you try to evaluate different marketing initiatives and then see which one would be better, right? So that is very standard. And last one is regression. As I said, this is the most single useful tools in statistics. Of course, these tools rely on the thing we learned before, but this particular tools is trying to understand how variables are related, right? Because we are trying to learn from input to output, right? That's something that we try to learn. And for example, we want to learn if I study more times in the library, is it going to help my GPA, right? Or if after you graduate, you want to study a master, is the master is going to help you getting higher income, right? So that is the question regression trying to ask, right? And it's trying to look at the data and see people who have the master don't have master, right? And do they earn more, right? Of course, the thing is things are getting more complicated, right? Because people getting master, maybe they're more smart or maybe they're willing to take risk. Then you have to control those things, okay? That things become more complicated. But we're trying to understand cause and effect. That's a regression. Okay, but I think it's a little bit weak at the moment. But I hope you have some idea what's going on for this whole course. So before we have a break, I want to go over the projects, okay, which is as I said, it's an open-ended assessment, and the deadline for this will be the Sunday of the last week. So the semester ends, or our test actually on the 2nd of December. This will be the 4th of December, where last. Okay, don't worry. It's not something that workload is not heavy, but the learning process is very important. Okay, and but just first is a project that can be group or can be individual. Okay, and you can do it by yourself, but you can do it with classmates. Because of the COVID reason, I allow you to do it by yourself. Usually, I wanted to do it at least more than one person because group team spirit is very important. But COVID, sometimes it's very difficult to do group work. And I don't put restriction on group size except you at most is 6. Okay. The reason I put 6 is because you cannot have the whole class have the same group, right? And also there's a more than 6. Usually you don't actually require more than 6. And from the past data, I mean, at most is 4, but I allow you more than that. And if you really doing a very big project, let me know. I can make an exception if you really show me that you are doing a big thing. And because you don't need to tell me what is your group members. Okay, I don't accept any complaint that your group mate is not working. If he's not working, you just drop him. Because you only submit your thing at the end. Okay, you don't need to ask me to approve a topic. You can just do whatever you like. Okay, of course, if you want to confirm whether you are okay, your topic, you can email me, but I would not give comment except your topic doesn't really work out. But usually from the past, I mean, only 1 or 2 people send me, and at the end of the work, everyone's okay. So I don't see a particular reason why your idea would not work or not difficult. And if you submit a group, I assume everyone contribute equally, unless everyone agree one guy is not doing the job, okay, including that guy who is not doing the job. Okay, so otherwise I would assume equal contribution. Okay, you have to handle any fee writing about your team. If you form the team, then make sure that you make sure that everyone do it fairly. If not, I assume otherwise. Okay. So the only thing I want to mention is the page limit is 1 A4 paper, both sides, for each person in the group. If you do it by yourself, just 1 page. If you do 2%, 2 pages, 3%, just 3 pages. So I explicitly don't allow you to go overrun because I worry about overwork. And because you should focus your work to make your thing perfect, right? Focus on your how to think of the problem and write nicely. And also the reason why I put a strict page limit is the business world, people have no time, okay? Even people not read more than 1 page, okay? Actually 2 pages is already more than it should be for business application, okay? But I allow you to get 2 pages, but try to be short. I mean, you don't have to fill up the page limit. As later I will show you the example. Actually, you don't have to go over it. And this is some guideline. I mean, I'm not going to go over it. Instead, I go over some example I got last year. Okay, so you can see this is coming from the black box, the project, the example zip file. So the files here are the project that is above average. Okay, this means this is a project get an A minus or B plus. Okay, but but they do have some merit. I mean, something that good here, something bad here, but I just put there in case. Okay, so this one is not directly related to business, but related decision. So here is there's a team of 2. Okay, I think it's Korean classmate from last year. So they try to compare whether hard code and clay cloth is it going to make a difference between surfing. Okay, so just trying to see if different type of environment will affect your playing. Okay, so whether you got an ace or double fault depend on your hard or clay or grass. Okay, and what they found for couple testing is try to compare the 2 things based on the data. Okay, so what they figure out is there's no difference between hard and clay court. Okay, they're the same. Okay, and look at double fault rate, doesn't really matter. I mean, so but the ace race is higher in the hard court than clay court. Okay, and that's what they found. Okay, so this is unrelated to business, but I think that is interesting. Okay, they look at the data and then collect data from, I don't know, ultimate 10 statistics. Okay, and do it in Excel. So I think it's rather interesting. And let me go to the other one. So this the project work on the Netflix. So they try to understand the consumption pattern between different gender, male and female, different region, whether you're from Hong Kong, you are from Thailand, you are from different area, and how happier they are. And the tools they use is all 4 tools I mentioned, right? Regression, ANOVA, hypothesis and estimation. Probably now is still new to you. The reason is that's what you learn from this whole course. So I show you the end goal, what you're doing, right? So that is the thing you learn at the end. So more like learning objective. That's why I'm showing you this. So what they do is they try to ask people, look at the online survey. I think at that time, this last year, they still only do it on online. So ask the gender, where you are, how much time you spend, do you like it, and so on and so forth. And this is data that's equally male or female, and I think most of them are Netflix user. Okay, the question is male or female, who is going to watch more, right? So I look at my family. I don't watch Netflix that much. My wife do. And look at my son. My son watch more than my daughter. So at my home it's like equal, right? But what happened in the real world, you can see the data they have is they try to see yes or no, and they said no. means from the data, male and female is rather similar. Okay, you cannot say men watch more, okay, from the data. But maybe they just don't have enough data, but I don't know. Second, they're trying to look at whether location would change. What they do is look at people in Thailand, look at Hong Kong. What they focus on Thailand or Hong Kong, I think I remember asked is the data availability. But anyway, they figure out that given female and male the same, is it Hong Kong and Thailand make a difference? And they figure out that, yeah, there's no difference between Hong Kong and Thailand. Still male and the female are the same. And they try to look at whether watching Netflix more getting you more happy or not, right? Because you watch Netflix, maybe make you happier, right? And because you're happier, you watch more, right? Or you're not so happy, you watch more to get the better movie. Until they figure out that is negative related. So what they look at the graph is like this. Okay, you got a negative relationship. So you watch more, actually you're less happy. Okay, and that's the estimation. So maybe go to the next one. This is the last one we want to cover. So well, last one. This one looking at income of young adults. Okay, so and the expense. So look at the adult like you guys. How much they spend is related to how much they earn. Okay, is it girls spend more or boys spend more? Is boy earn more or earn less? Okay, young adults. So they look at men. So what they do is to collect some data questionnaire. I think they do it in the, I don't know where they do it, but they didn't say. But what is the result they got is very interestingly. They show the data. Probably you know at the end of the course, you know what the graph means. But what they show is men earn more in the data. Okay, men earn more in the data. And whether men or female, the spending, they're the same. Okay, so in the data they show men earn more, spending is roughly the same. And then is it people earning more, spending more? Yes. So they are possibly related. Okay, so and that is it. And I don't want to take more time from you because I'm overrun already. So this already have everything. Not all the project, but I think I put the project that at least have some interesting thing goes on, so you can take a look. I think I put this year, last year as well. So last year and the previous year as well. So you can take a look. You can see a lot of topics that you can explore. Okay. And any question so far? And after break, until 12:30. If you want to drop the class and you can just go, you don't have to tell me. So after break, 15 minutes. So in the meantime, I'll walk around. And if you want to anything to say to me, then please do so. So have a break. And when we come back, we will start our class looking at the topic number 1.
No, we're just giving them that. And we just say that they've been there, so still be a special. Exactly.
People from Zoom, any question for you? So since there's no question, let's get started. So today we're covering the topic 1, descriptive statistics. So all the slides of this whole course are uploaded. I think there will be no changes except maybe 1 or 2 typos. After 2 years, I think the typo should not be there, but because I add some new slides, 1 or 2 slides, so there might be a little bit typo, but let me know if there's some, but I think more or less is there already. So you can see this first topic slide has staggering more than 100 pages. Don't worry, actually we will have 60 pages slides, and remain 60 at the Excel. Okay? And you may, some of you ask me during the break whether you need to bring your laptop or thing, but I think I see almost of you have the iPad already, so iPad cannot Excel anymore. So shouldn't be an issue. If there's an issue, I think also fine. You just bring your, you just see what we do in the class and complete it. Already. Also, we have the I think we have the Zoom record, so we shouldn't be an issue in case you really need my help, or you can ask a TA. Okay. So topic 1, descriptive statistics. So what we're going to do today is this one. So if you learn statistics like what I do 10 years ago at 6K B school, actually this class is divided over 2 semesters. The first semester focus on the first 3 topics we cover, what we call the descriptive statistics, which is look at the mean, median, and variance, those kind of things. Look at probability theory, random variable, and this already whole semester. Okay. And then the next semester we'll be covering the hypothesis testing, sampling distribution, ANOVA, regression. That will be the second semester, what we call the inference statistics. For the descriptive statistics, which means you have the data, you try to get info, you try to describe it, you do not create new knowledge. For the inferential statistics, you try to get new knowledge from it, okay? That requires probability. And that's the most useful part, right? Because that is something you get something new from there. You try to do some prediction, right? And important line estimating the elastic demand, predict economic growth, look at the movement of the stock price, right? Those kind of things will be important, right? But first, we need to know what we care, all right? What we call descriptive statistics. So before we start, we have to talk about some terminology. First is the data classification, okay? And this is very important, although this single slide, we only mentioned once. And this will be crucially important to determine the tools for use. Why? Because different tools will require different data. If you use the wrong tools, then you get a misleading result. Okay, let's look at it first. Okay, in the data, usually you divide it into 2 parts. There are many ways, but there are 2 ways I find useful. One is called categorical, the other is numerical. Okay? Let me mention the numerical first because this one is the most thing you would think easily, right? For numerical data, there are 2 types. One is called discrete, one is continuous. Discrete means that there are finite number of them, that can't find or infinite, but countable infinite. right? Just like 1, 2, 3, 4, 5, right? And you have 1 kid, 2 kids, 3 kids, right? There's no meaning of 1.5 kids, right? Some intermediate value have no meaning, okay? Right? You have 1 customer, 2 customers, 3 customers. There's no meaning of 1.2 customer or 1.5 customer, right? So the middle number has no meaning for discrete, right? Continuous means any value is valid in between is also, right? Just like temperature of rice, right? If the stock is $1, it's possible. $2 is possible. $1.50 is also possible, right? Any intermediate value will be possible. Okay. So these are 2. And for these 2 type of data, usually all the tools, most of the tools are applied. You don't have any problem. Of course, there's some issue or some difficulty in discrete continuous. Okay. But for the tools we learn, usually it's not a big issue. Okay. But the main problem comes from categorical data, which they might pretend themselves to be numerical, and that would be an issue. Okay. And indeed, actually there's a statistics called categorical data analysis that focus on this particular set of data because they require different tools. Okay. And the first thing is like the nominal data. It's like gender and race, right? Gender, maybe male or female. Usually when you look at data, it's under 0. Okay. Although we put number there, the number is meaningless, right? We can say man is 0, woman is 1, or man is 1, woman is 0. It can be worse, right? The numbers don't mean. You can say man is 2, woman is 100. The number has no meaning. Okay? Race is sort of same. Okay? You put a number in the data, doesn't mean anything. Okay? Has no meaning. And second one is ordinal. This one is little bit is even more deceiving because the number do have some meaning, okay, but they don't have the traditional meaning more important. Like ranking, which means that usually higher the number the better, or sometimes lower the number is better, right? Something like you try to look at say Miss Hong Kong, right? Number 1 to number 2 to number 4, or Olympics, right? Number 1 to number 4, right? But the meaning is not the same, right? Say suppose look at the Olympic Games or some sport competition. Number 1, the first one is better than number 2, right? Number 2 better than number 3. But is it different with number 1 and 2? Same with different number 2 and number 3. Right? Usually not. Right? Say Miss Hong Kong or Mr. Hong Kong, right? Number 1 guy, maybe the most beautiful or handsome guy. Okay? Maybe you do better than the second one, maybe not, but at least the difference between 1 and 2 is not the same between 2 and 3. Okay? So that will become easy. Why? Look at the most common ordinal data you see in business world or in the real world. Look at the e-commerce platform like HKTV Mall or Amazon or Tmall or Jingdong, right? All you see is a Likert scale. You the rating. Okay? You rate the product will tell you the rating is from 1 to 5, right? Say this product is 4.6 or 4.9, right? What is that number? Okay? Actually, you would, when you try to rate the product or the merchant, you would give either disagree, agree, neutral, or strongly agree, right? It's 1 star, 2, either it's 1 star, 2 star, 3 star, 4 star, 5 star, right? Different hotel, or you get a 5-star hotel or 4-star, there's a criteria there, right? But to tell you the satisfaction is not very clear, right? But all the time you calculate, all you see the date number there is average, right? Is you see the product, the rating is 4.6. What does that mean? Okay, is you would say disagrees 1, sorry, disagrees 1, disagrees 2, usually is 3, and so on and so forth, right? And you calculate what's the number, there's an average of those numbers. Does it make sense at all? Well, it's not entirely clear. Why? Because you calculate average, later you will see soon. It has to be talking about numerical data, okay? Where the difference will make sense, right? Because you have to be the difference between 4 and 5 to be same as 3 and 4. Otherwise, we calculate the average and mean alone. Okay, so that's why one of the rule of thumb that some people told me, when you look at this kind of thing, look at the number there, is look at what should be the distribution of that. Is that a lot of people get a score of 1? Okay, who is complaining? Look at the Amazon, right? People say, okay, you shouldn't look at the score only, but also look at what people complaining. Look at the 1, right? Because there may be a lot of people here, but only 1 there, right? And look at those complaints. So that is the reason why when you calculate the mean, applying to this can be very misleading. Okay, there's no point of talking about this. This is basically more or less very misleading thing. Calculating this based on this is, I don't know, it's very hard to say. But anyway, a lot of time people rely on this ranking, average of ranking, but it's unclear what they mean because the difference between different number, different scale is no particular meaning. Applying mean can be misleading. Look at the median, look at the distribution would be more useful. But later we will see why. Okay, so that gives you the idea why you have to be very careful about the data. I mean, very often we're looking at this continuous data or this discrete data. Okay, that would be no problem. Don't worry. But when you apply to categorical data, you should be very careful because actually you require different tools. I mean, we didn't cover in our class because there's advanced class to cover that. But just to make sure that you don't fall in the trap. Okay, I will not mention this anymore, but that will be end of it. So the next thing we want to talk about is the visual representation. Okay? In this class, we only cover the numerical one. Okay? The visual one we don't cover anything. Okay? Because as I said, this is to be covered in your primary school or even kindergarten. Okay? So I hope if you don't, check it out. How to draw a bar chart, how to draw a pie chart, how to draw a histogram, how to draw a polygon. Okay. For the scatter plot, which is something we cover, so we don't have to worry. So the first 4, if you don't know, go to Wikipedia, go to Google, go to whatever website, you can check it out. Okay. Or if you really don't know, you can ask here. Okay. I'm not sure he will be happy, but I think at least he will answer your question. I hope. Okay. So what we're going to learn from this topic would be we focus on these 3 things. Okay. For the data, we want to look at 3 different elements. First one is called center tendency. The second one is called dispersion. The last one is called shape. Okay. And the first one, center tendency. That's good. Center tendency is a single number that tries to represent the whole data set. Some questions from you? Oh, sorry. Can you hear me? Sorry, sorry, I didn't have the mic on. So next time you may try to remind me if I cannot have the mic on. Is that okay? Sorry for I didn't notice. Okay. Maybe I speak too loud, so probably without the mic you can still hear me. But so we look at the center tendency, and this is something we want to have a single number to represent whole data. So probably you learned it before as mean, median, and mode, and I'm sure you know it very well. So we will focus on telling you what are the pitfalls and what are the reasons why we use them, and then you know which one to use. Of course, in the real world, we use 3 of them. You don't rely on single one, but you need to know what is the best one, right? Because and later you will see how to choose between these 3, right? As I mentioned already, if your data is categorical, mean is not very useful, right? And you would use median or mode. Okay, even median may not be useful because there's no middle in the meaning, so you should use mode. Okay. And after that, we look at the dispersion. Okay. Dispersion will be, say, how data are spread out, means how good is the central tendency looking. Okay. How spread they are. Okay. And then the next thing, look at shape. Is not covered in the high school syllabus, and what are they? Okay. The first thing is look at the skewness. It's talking about whether the data is symmetric. Okay. And if a lot of outlier at one end or the other, then it's skewed. For example, the most commonly skewed thing you can imagine is income data. Okay. Look at income in every economy. There will be some guys that earning a lot of money, right? In US, maybe Elon Musk earning huge amount of money, right? In China, maybe Jack Ma making a lot of money. In Hong Kong, maybe Mr. Lee earn a lot, right? There are many Mr. Lee in Hong Kong earning a lot of money, have a lot of power. Anyway, multiple Mr. Lee, not the same one. But anyway, if you include the salary data, me and Mr. Lee, right, then will be a lot, right? Or Elon Musk will be a lot of money, average of those. So in those cases, that's why when you look about the income data, we don't talk about mean, we talk about median. Okay? When the data is skewed, median is better than mean. Okay? So that's why we look at the skewness. Okay? When you have data you want to report, what are you going to report? Look at whether they're skewed or not. If they're skewed, you should report median rather than mean. Okay? So that's why this is something the first thing we look at, right? The next one is kurtosis, something I think is new. Looking about whether you have a fat tail or thin tail. What is it about? You're looking about, look at the outlier, extreme value. Are they a lot of extreme value or not so much extreme value? Okay. If the data we only have, okay, several people earning a lot of money, that's okay. Maybe that's by lottery, by luck they're doing that. If there are huge amount of people, I mean, not trivial people earning a lot of money, I mean, then it's an issue. Okay, it means that a small group of people earning most of money, there is a big issue there. If just 1 or 2 person earning a lot, it's not a big deal. The society is fair, but it's a lot of group of people earning a lot of money, that's a big issue. That is with a fat tail. Okay, so the other applications talk about calculating the risk. So if you from finance or insurance or actuarial science, then you would be worried about whether the data you have, the stock price or the loss data, is a fat tail. Okay. For fat tail, it means there's some catastrophic risk. Okay. Look at financial market. Okay. You will expect the price fluctuate up and down around certain range. Okay, every day, right? But if the stock price they go down by 10% in one day, then it's a huge loss, right? Or maybe 20%, 30%, right? And that can be a problematic thing, right? And if you don't take into account into a data analysis, that would be a problem. Okay. And kurtosis would tell you whether your data fat tail. And why we care about fat tail? And the reason is when we look at the data, okay, when we make some inference, when we make some analysis, most likely we will be doing what we call normal distribution, which is called the bell shape. Probably most of you will know. And in the bell shape, the tail is not that fat. Okay. When I talk about fat tail later, we will see is whether the tail is fatter than the bell shape. If fatter than bell shape a lot, then the issue because what you do is underestimate, right? Because probably most of you will learn some what we call empirical rule. You would say in normal distribution, most of the thing will be within 3 SD, right? 3 standard deviation. But with the fat tail, it's way more than that. Okay. And that's a problem because a lot of calculation is based on this, what we call 99% rule, right? Or 3 SD rule, or 2 SD rule. In that case, we fail to take into account can be issue. Say, for example, some people said the reason why you have, say, multiple financial crises in the past 20 years, like the 2007 financial crisis or 1997 Asia financial crisis, are all due to failure to take into account of the fact tail, right? Because the subprime mortgage is something unseen, and a lot of the position created by hedge fund is based on that no fact tail. Once they have this, then they calculate the formula all wrong, and they all got jammed, and a disaster happened. Another example would be, as I said, the Asia financial crisis, right? People don't expect things to go wrong, say in Indonesia or Russia. The sovereign debt has actually defaulted, right? No one expects Indonesia default their debt, and also Asia country that default their debt, and Russia also. So make a lot of funds that go bankrupt because of this. And this is the failure to take into account of the fat tail, because they think it's everything within 2 SD, then everything is safe, right? Or 3 SD. So these two are very important, and it's something different from what you learn in the high school. So I hope we can go over this, then it will be fun. Sorry. So that would be the 3 topics we cover for this one. And then after this, we'll talk about Excel, how to do all the calculation in Excel. Okay. Any question before we start? Is that okay, people from the Zoom? Okay. The first thing, central tendency. As I said, probably you know it. I just going to be brief. Okay. But before we do it, we have some notation. This notation we'll be using through our slides, and also actually appear in the textbook as well, and the standard one. So we have a small letter n refer to how many number of observation. And each observation will be denoted by x1, x2, and up to xn. Okay, so x is the observation number. Okay, just say algebra there. X is just a number. And we have cost summation notation. This is what we call sum of 1 up to n, means that we adding up n. Okay, and there will be 2 rather tricky notation here. It's called the floor ceiling function, or what we call round down and round up. If we 3.1 for round down, it's just an integer. Okay. And for the ceiling, okay, we'll take the integer part. If the decimal part is non-zero, you just add 1 to that one to round up. Okay. So if 3.0 is still 3, but 3.01 will be 4. Okay, so that is. And you may ask why we want all this thing here. So this is how you write program, right? When you Python out, this is just a for loop. Excel is just a little bit different, but for B.B.A you can also do the loop for loop. And this round up and round down also you can do in Excel. Okay, and this is a very important function. Later you will see when I present the formula for median, we need these 2 functions. Okay, you will see very soon why we need those notation. Okay, so second, we define what is the sort data. Okay, something you know easily. It's just like we sort the data from the smallest to the biggest. Okay, so basically we order them. X1 is the smaller, X2 is bigger, and up to xn. So it's okay, x1 equal to x2, so it is less than or equal to sign. Okay. And the next thing we learn, I mean, you have learned in the high school, or is what frequency. Frequency is number of observation the same value. Okay. That means that if say x1, x2 are 1, then x3 is like more than 1, then the frequency of 1 is 2. Okay. And that gives us the following table we call frequency table. Okay. And Suppose we have data 1, 2, 3, 4, 1, 2, 2, 3. The frequency of 1, the frequency of 3 is 1. Frequency of 2 is 2. Okay. So this is what you learn from your high school, right? Or elementary school, or even kindergarten, right? Frequency is number of observation have that value. Okay. And last one, I think last one, I guess. Yes, last one, we call the contingency table. Okay. So with the number of students, here is we have 15 students actually are male and passed exam. And we have 20 students, which is female and passed exam, so on and so forth. Okay. So we say what we're doing here is to represent the data. Okay. Not in terms of just frequency, right? If pass and fail, right, is easy, but we are looking at the data that has some categorical variable, right? Each data can be pass or fail, right? And can be male or female, 2 groups. Okay. And that will be useful when we talk about ANOVA. But for the moment, we just learn this at the beginning. This one, we will come back very late on this part. But just introduce it here at the beginning, because this is something you learn when you are in the high school. Okay. Because this is just representing the 15 male that passed. So nothing new here. Okay. Now we are lucky that we can get to the real business. Okay, the real business is the mean. Okay, and mean has nothing. Everybody knows how to calculate, right? Just adding all the observations divided by how many of them. Okay, just notation, summation, summing 1 up to n, and this is right. So there's nothing new here. So then I want to talk is what is the meaning of X bar? Why is it central tendency, right? And probably you know, if you write this formula here, you subtract X bar from both sides. Okay, what you get is this notation is equal to 0, right? Because you subtract X bar from both sides, right? In this equation, you subtract X bar, this becomes 0. You subtract X bar is minus X bar. Okay, every observation. Right? So that gives you this equation. Okay, that means that if you take each observation, you minus X bar, adding up them is 0. What does that mean? What does that mean? Okay, this has a very interesting meaning. Probably you learn in your high school already. I think you should, but let me write down the interpretation is here. So consider this number line here. Okay, X, right? Maybe this is 0, the negative positive, but anyway. So consider our data here. This is X1, right? And this data is X2, and maybe X3, X4. Okay. So what is the mean of this data? Okay. And probably you will guess right. The mean will be somewhere in the middle, right? I mean, probably I use the other color, the black. Somewhere in the middle, X bar. Okay. But what is exactly the location of X bar? Okay. X bar is saying that we find in the middle such that the distance from each observation to the left of X bar, same as the one to the right. What do we mean by that? Is the following. Suppose I use a green color. Okay, this distance to the left, and this distance, the green color, same as the purple color distance. Okay, X bar is located in the middle of the data, means that such that is the distance, some distance to the left of it, same to the right of it. Okay, so it's the meaning of the distance wise in the middle. Okay, let me So why is it the left and the same as right? It means this guy, right? You may ask why this is the case. Because, right? Because look at this one, it's negative, right? Maybe I used the green color, right? It's negative, right? Because this is smaller than the observation is smaller than the mean, right? And look at this, all positive, okay? When we say they add up to 0, means that the sum of the distance with green is same as sum of the purple, right? So it's the middle in the distance sense. So that's why at the beginning I mentioned about when you have a Likert scale, agree, disagree, those kind of thing, calculating mean is not so meaningful, right? Because only meaningful when talk about distance with the same, right? But when distance has no meaning, right? You calculate middle of distance, what's the meaning of that? Okay, so that's why when you see whether this measurement has meaning, you have to understand what is the intuition behind, right? Although the formula, everyone knows it, just adding up divided by how many of them, right? But the meaning is middle in terms of distance. Okay, so you have to make sure that your data has a meaning, right? And then it will be useful. And second thing, you can see this is middle in terms of distance, right? So it means that when you have x5, suppose the data x5, which is way at the end, okay? Maybe somewhere here, okay? Then what happened? Your x bar will be way even bigger than x4, okay? Maybe we're close to, for example, what I exactly mean is suppose there is a, I use another color, maybe orange, somewhere here x5, okay? So can you see? Maybe not orange color, maybe black, okay? Maybe x5 is here, okay? Then x bar may be beyond more than x4, right? And then in that case, what's the meaning of mean? It's not very useful, right? Because it is unrelated to majority of data, right? So that means that mean, because of the equalizing the distance from the left and the right, if the outlier, then your data will be screwed. Okay, so how do we rescue this kind of problem? We will talk about soon, but this is the meaning of the mean. And probably you notice I put this box as gray color. The meaning of this is this slide is technical. I'm not expecting you to, I'm not explicitly asking you in the exam, but it's good to know, just I put it there, okay? So the thing you should know is something like the blue color thing you should know, okay? I expect you to know, and you will be tested in the assessment in terms of exam or assignment, okay? The gray color is just for fun. I'm not sure it's fun, but I hope you know, but it's okay, you not remember it, but you better know it, okay? So this is example, green one, I also expect you to know because this is something will be asked in assignment and also possibly in the test as well. It's application usually, right? It's applying the concept, you should know it. And if you have any problem with your assignment, usually you go back to look at the green boxes, then you should be able to do it. So we have a 2 data set, 1, 2, 3, 4, 5, and the other one is 1, 2, 3, 4, 50. And calculation of the mean will be trivial. I'm not going to go over it, but one is 3, one is 12. As I said, right? You can see when you change the last item to way big number, the mean explode. And 12 is way more than 1, 2, 3, 4, right? In this example. And you can see, looking at the mean has a problematic thing, right? And a lot of time, we collect data, it happens something like this. It's not unusual to have seen something like this, right? Look at data of a shop or look at a platform or a restaurant, right? There may be one guy very rich buying so many stuff, right? And then you estimate the average, probably not very useful, okay? So you may ask, okay, since mean has a this problem. So how can we do about it? There are several ways. Okay. One way is to what we call trimming. Okay. Basically is if we have data that's super big, we just cut it out from our sample. Okay. So take out 50 and the trim data is 1 to 4. So the trim means 2.5, that's okay. Okay. So the question is what to trim, right? How can we know what to trim? The question is very simple. There's a systematic way to trim is you cut the top 1%, top 5%, and top 3%. Okay. There's several percentage what you can cut. You can arbitrarily say, okay, 50 is outlier, just cut it. No. You look at the data set, you can, the bigger you have, you can cut more, but usually you cut 1%, 3%, and 5%. Okay. So that is the way. And the other is called censoring. Censoring is just similar, but instead of cutting out of it, just replace the last guy with, say, the smallest one. If you have smaller guy, you replace the smaller one. Okay. Suppose you have the data is negative 500, then you replace with 1. Okay. So we just replace the outlier. And replace outlier, the winsorized one is more because you censor in this one. So, but still, no matter you trim or you censor, you winsorize, or sometimes you call censor. But anyway, you call winsorizing or trimming. The data you get is more reasonable. Okay, so this is how you actually do things in practice, is doing some data cleaning, okay, some data manipulation. Okay, and as I said, this manipulation is not, there's a procedure to do it. Okay, it's not arbitrary. Okay, there's a well accepted, it's like, as I said, 1%, 3%, 5%. Okay, and also you cut out the top 5. So that's how we do it. And here I talk about other type of mean that is very useful and also commonly observed in the real world. And the weighted mean here actually covered in the high school syllabus, but we just put it as a technical part. And here is weighted mean is saying each observation does not have equal weight. Some observation is more important than others. Okay. So the calculation is very simple. It's just each observation of weight, Wi, and you multiply each observation by its weight and over sum of the weights. Okay. And in case of the standard one, each observation, the weight is 1, equal weighted. When you Wi are 1, then go back to the original equation we have, right? Or any number of a 2 or 3 also fine. Any number, if the same weighting, you go back to the mean we have, simple average. Okay. The question is why we need to put different weights on different item. Okay. Actually, you know from the GPA, it's a weighted mean rather than simple mean. Why? Because some classes are more important than others, right? Like our class. Our class have 4 credit. Okay. Compared to other class and 3 credit. Okay. Compared to other courses, we only have 1 credit. Right? So it's important to get A in a class than other class. Okay, study harder for our class, please. So this is a grade point average, right? You know how to calculate, right? Same here, if you are doing investment, a useful indicator is called moving average, right? Looking at the moving average. And this moving average, there are many versions. One particular version you look at, you care about more recent prices, okay? You put more weight on the recent prices. Right? Because what happened in the old day doesn't mean that matter, but more recent development of the stock will be more important. So that's why it's a moving average or weighted. And the other is when you calculate portfolio, the same, right? And then it's weighted average of each investment weighted by your portfolio weighting, right? And finally, Hansen index, right, is a weighted average of largest 50. I think they changed to 70 now. Sorry, this is so some changes, but 50 is old day. I think now it's 68 or 70. But anyway, so basically just like the average of those stocks, it's a weighted average. Okay, so it's a single number trying to present the stock market, but because of some stock, not all the stock are equal, right? So we take into account in those, and the bigger stock like HSBC or Alibaba or those kind of stock will be more important, okay? So that's why you put more weight for your mean to be meaningful, okay? You just simple average doesn't really make much sense. Okay, it's weighted average. I mean, and just telling you how to do the calculation. This example here, again, 1, 2, 3, 4, 5. We're weighting. Number one have 6 weights, and we're 3, 2, 3, 2. And simple average, same as before, but weighted mean that will be you multiply each observation by its weight, so on and so forth, divided by sum of the weight. Okay, and you can see this number weighted average is smaller than the raw mean. The reason is being that the weighting for the lowest observation 1 has a high weight, so that's why it's lower. And this explains why the weighting can be crucial, right? So, and again, explain you why you want to get a good grade for your high weighted course. So study more for our class. And here we have 2 more things probably you learn in other class as well, but we don't put much emphasis. One is called geometric mean, the other is harmonic mean. Harmonic mean can be useful, but I don't think we need to cover. But geometric mean I will talk about a little bit because it's related to investment and related to what we call the compound interest. Okay, let me talk about it in the next slide. But the formula is very simple. Just depend on how many of data you have. Okay, instead of adding, you should multiply them and take the n square root of that. Okay, if 2 elements there, you multiply and take a square root. Okay, and why is it important? Because this, look at the investment. Okay, this is a classical example. Look at the investment textbook. It's the benefit of or the power of compound interest, right? So look at 2 investment. Option 1 is 10% year, and option 2 is option 1 is 10% year 1, 90% year 2. Option 2 is 50% for both years. If you calculate simple average, they're the same, right? Because average of 10 and 90 is 50%, right? So you should if you look at the simple average, you should be indifferent between the 2. Okay, but if you think that you have reinvestment opportunity, okay, if you compound return, what you earn the first year, you can also put that in there. Then you would think actually 2 is better. Okay, because you earn 50% more and you earn 50% again. So you have the extra 50% more to earn 50% more. Okay, so in that case, how you compare these 2? Okay, is look at the geometric mean. Okay, and turn out to be this is compound return. Look at this, right? It will give you 109 and this 125. So you would prefer option 2 over option 1. Okay, but I'm not going to detail of this because this is supposed to be covering the investment. But I'm trying to say that geometric mean sometimes is useful. Okay, but we're not going to cover those in our class, but just some idea we're covering. Okay, I hope that gives you the idea of mean, and you know the mean meaning is a middle by distance. Okay, the last 2 minutes I want to talk about middle by location. Okay, which is called median. Probably know it. Okay, and we don't care about the distance. We don't care about, we sort the data, look at exactly middle guy, what it is, right? And the exactly middle guy will exist if the number of samples is odd, right? Suppose the data 1, 2, we have 3 number of data. Okay, n is 3. The first and the second and third observation. The exactly middle one is second guy. Okay, that's no problem. The problem is when we have even number of observations, is say 1, 2, 3, 4 observation, and the middle will be 2.5, right? So how do we do about that? Will be we use the mean of 2 middle, okay, get the average of 2. So if you have 4 observation, you're getting number 2 and number 3, right? Average of those. So that's why the median actually rely on the mean, right? The mean of the middle, okay? Now, so you can see even though middle is very simple, it's rather difficult, right? N is odd, is this, means even this, right? So you may ask, is there any way to simplify this too? Yes, it's what we use the round down and round up function. Okay, so that's why we need that. And you may ask why we have this, because instead of this, because when you write Excel or R, this will be easier than writing this statement. Right? Because you need to write if statement, this is just one line, you're done. Okay, but what is this particular meaning here? Okay, here when it's odd plus 1/2, this data exactly exists, right? N plus 1/2. Odd plus 1 is even over 2 is a number, right? Say 3 plus 1 is 4/2, right? This data exists. But if say N is even, say number 4, N is 4, 4 divided by 2 is 2, 4 divided by 2 is 2, 2 plus 1 is 3. So it's second data plus the third data got the average. Okay. Lastly, I want to explain why this is the same as what we have. If this N is even, so it is odd, it is odd, plus 1/2, okay, is a integer. So these two are the same, no matter you run up and run down, the same. So exactly give you back this guy, right? And if this is odd, so if this is even, this plus 1 is odd number, okay? You want to take the integer part, right? And it's about plus 1. So that's why this is exactly the same as this one. Okay? So overrun by 1 minute, but I will see you next Wednesday. Enjoy your mooncake. I stay around to answer any question you may have. Any question from your Zoom? If no, enjoy your mooncake.